Today we're going to be looking at radical equations and problem solving. Our first problem is the square root of 3n minus 5 equaling 4 squared. Well, in order to undo that radical sign, we know the opposite function is to square it. So when we square it, that radical sign goes away and we're left with 3n minus 5. We also know 4 times 4 is 16. We add 5 to both sides to find that 3n equals 21, but we don't want 3n. We want n, so we divide both sides by 3 to find that n equals 7. Our second problem is the square root of 8x plus 5 plus 2x outside of the radical equals 0. You always want to move that stuff that is not under the radical to the other side, and we do so by minusing 2x to both sides of the equation. Then once again, to remove the radical, we square that, and when we do that, we get 8x plus 5 equals 4x squared, because a negative 2 times a negative 2 is our 4, and x times x is x squared. Moving the 8x and the 5 over to the right side, we subtract both of them. And this quadratic equation, 4x squared minus 8x minus 5, factors quite nicely into 2x plus 1 times 2x minus 5. Setting each piece of that equal to 0, we find that 2x plus 1 equals 0. Minus 1 to both sides, and then divide by 2, we find x is a negative 1/2. So the second part is our 2x minus 5 equaling 0. We take the 5 over to the other side and we divide by 2 to find the other solution to be 5/2. Our next problem is the cube root of y plus 3 with a plus 7 outside of the cube root equaling 5. Again, we want to move that stuff over to the right side first, and we do that by subtracting 7 to both sides. And we find that we have the cube root of y plus 3 equaling a negative 2. Just like squaring gets rid of the square root, cubing gets rid of the cube root. So we did that on the left side, and we've just got y plus 3. But what we do to the left side, we always have to do to the right side of the equation. So when we cube a negative 2, we end up with a negative 8. We don't want y plus 3, we just want y by himself. So we minus 3 to both sides of the equation to find our answer of y equaling a negative 11. Our next problem is the square root of 36 minus s equaling s plus 6. Once again, we're going to square that square root in order to remove it, and we end up with 36 minus s. But what we do to the one side of the equation, we also have to do to the other side, and we're left with s plus 6 squared, which when we FOIL that, we get s squared plus 12s plus 36. Minus 36 to both sides, and the numbers go away. And we're left with a negative s equaling s squared plus 12s. We add s to both sides of our equation, and we find that 0 equals 3 squared plus 13s. 0 then, if we factor an s out, equals s times the quantity s plus 13. Setting each of those pieces equal to 0, this one is just s equals 0. And then this is s plus 13 equals 0. Subtracting 13 to both sides, we find that s is a negative 13. So we check our answers if we want to by plugging them in the original equation. If I put a 0 in here, I get the square root of 36, which is 6, and a 0 in here, which is also 6, so 0 does work. But when I plug a negative 13 in here, I get the square root of 49. And I put a negative 13 in here, I get a negative 7. And it does not work. The square root of 49 does not equal a negative 7. Our next problem is the square root of x plus 1 plus the square root of x equals 5. So we move that square root of x over to the other side by subtracting it to both sides of the equation. And we're left with the square root of x plus 1 equaling 5 minus the square root of x. Once again, we square to remove that radical, and we're left with x plus 1. Over here, when we square this, we have to FOIL it, and we find that that's 25 minus 10 times the square root of x plus x. Taking the x over to the other side, minus x, those go away. And minus 1 from 25 is 24. And plus 10 times the square root of x, taking that to the other side, we're left with 10 times the square root of x equaling 24. So once again, we have to square in order to get rid of this square root. And when we do that, we find that we get 100x equaling 24 squared, which is 576. But I don't want 100x, so I have to divide by 100. And when I do that, I get x equals 576 divided by 100. And if we reduce that big fraction by dividing each thing, the numerator and the denominator, by 4, we find that x is 144 divided by 25. Our next information is the Pythagorean theorem, and it's good for right triangles. It is a squared plus b squared equals c squared, where a and b are the legs of our right triangle, and c is the hypotenuse. So if we're given the legs of the triangle are 9 and 12, and to find the hypotenuse, we just plug it in that nice formula, and we get 9 squared plus 12 squared equals c squared. Well, that's 81 plus 144, which ends up being 225. In order to get c by himself, we take the square root of both sides of our equation at this point. And of course, the square root of something squared is just that thing, so we get c, which is what we wanted. And the square root of 225 is simply 15. So the hypotenuse is 15.